Okay, this is the video for lesson 87 for geometry. This is about area ratios of similar figures. Similar, the symbol for similar is that right there. So you're going to see me use it, you're going to see the book use it, so that's what that means. So if you have a scale factor, another word for scale factor is similarity ratio of A to B. That's your scale factor, that's your similarity ratio of A to B. The ratio of perimeters is A to B. Then the ratio of the areas is A squared to B squared. Ratio of the volumes would be A cubed to B cubed, but we're not talking about that yet. We're going to do ratio we're going to use the ratio of perimeters deal and the ratio of the areas. Given that we'll be given a scale factor or similarity ratio for the figures, and then we'll need to find a missing perimeter or missing area, something like that. Okay, so let's see. Got a rectangle, got a bigger rectangle, and this is 4x and this is 12x, and the perimeter of the smaller shape is 50. So we want the perimeter of the bigger shape. So the first thing we're going to do is take the two sides they give us and make a similarity ratio. And it doesn't matter which one you put on top. So we'll do 4x over 12x and then reduce that to 1/3 because the x's cancel. And 4 over 12 is 1/3. So there's my scale factor, my similarity ratio. So if I want perimeter, if I want to know perimeters, I'm going to set up a proportion using my similarity ratio, which is 1/3. And then the perimeter of the smaller one is 50, and I want the perimeter of the bigger one. And this is the way I want you to do this. I want you to set up proportions. I want you to find your scale factor, set up proportions, and solve the proportion because it's pretty easy to do. So the perimeter of the larger one would be 150 inches. Okay? So let's try a different one. I've got, it doesn't really matter. Let's just do rectangles again. This is, that's not what I want. This is 5, and because a lot of times there won't be an X there. So anyway, so there's 5 and 30. Or, okay, I've already done it. I'll make an interesting one here in a minute. So perimeter of the bigger one is, say, 400 centimeters. That's the perimeter of the bigger one. We want the perimeter of the smaller one. So we set up a proportion, 5 over 30. We get our scale factor, which is 1/6. So 1 out of 6. Now we set up a proportion. Since the ratio of the perimeters is the same as the scale factor, that's why I leave that 1/6 alone. So then I want perimeter of the smaller one, so that goes on top over the 400 because that's the bigger one. And then you go from there. 6p equals 400, and then divide by 6. So on these, you are going to put decimal approximations. 400 divided by 6 would be about 66.67 centimeters. Make sure you label. Make sure that you label. Do not forget to label. Okay, so that's how you find perimeters using this. Now we'll look at some areas. So I've got a triangle, got another triangle. Actually, let's not start with that one. Sorry. Let's start with this one, another rectangle. This is 15, this is 21. Got a bigger rectangle. And we are given that the scale factor or similarity ratio, that's the same thing, you're going to see both terms, is 3 to 4. 3 to 4, okay? So we want the area. We want this area right here. So we can find this area very easily, and then that's what we'll plug in. So sometimes I give you the area, sometimes you have to find the area. Here we have to find the area. It's easy to find the area, which is 315. And that's the way I want you to do it. I want you to find this area first. I want you to use proportion. I know it's not the only way to do it, especially if you've got the scale factor, but this is the way that it's shown in this lesson, and I want you to see how this works, so use the proportions. So if my scale factor is 3 to 4, when I set up my proportion, if it's 3 over 4, if I'm looking for areas, I've got to square this. It's got to be 9 over 16. Because the ratio of the areas, if you're given the scale factor, the ratio of the areas would be 3 squared over 4 squared. And so the ratio of my smaller one is 315, so it goes on top. And then I want, sorry, the area of my smaller one, not the ratio. The area of my smaller one is 315. I want the area of the bigger one. So then you have 9a equals 16 times 315, and then you just divide by 9. So 16 times 315 divided by 9 gives me 560. Wasn't given any units on this, but I want to go ahead and put units, centimeters squared. So I'll say that these were centimeters, and this was a centimeter squared, so that you remember to label, okay? So then another one, got a triangle here, bigger triangle, that's 25 centimeters by 40 centimeters. Sorry, that, now you can see it better. My scale factor or similarity ratio is 2 to 5. That's my scale factor or similarity ratio. So I want the area of the smaller one, because I can find the area of the bigger one just by doing area is base times height divided by 2. So base is 25, height is 40, divided by 2. So 2 would go into 40, leave a 20. 20 times 25 is 500. Centimeters squared. So that's the area of the big one. We want the area of the smaller one. I need to set up a proportion. Well, I know my scale factor is 2 to 5. So if my scale factor is 2 over 5, when I do areas, I've got to square them and get 4 over 25. And then I want my smaller area, and I've got the bigger area, which is 500. So then it'd be 25a equals 4 times 500, divide by 25. So 25 goes into 15, leaves a 20, which would leave 80 centimeters squared. Let me check my math. I did that pretty fast. Always like to check and make sure. Okay. So then the last one I'm going to talk about is example 4 on page 569 in your book, where you've got this trapezoid. So we're going to draw the trapezoid. The height of the trapezoid is 4 inches. This is 8 inches. This is 14 inches. 5 inches and 5 inches. Okay, so there's the trapezoid. It gives it to you in the book. And it's a landscape design company has created a plan for a large garden in the shape of an isosceles trapezoid as illustrated in the diagram. The diagram of the garden is in a 2 to 355 ratio. So there's my ratio. There's my scale factor with the size of the actual garden. Find the perimeter and the area. Okay, so we want perimeter. First, we'll look at perimeter. So I've got 2 over 355, because perimeter, we just keep the scale factor in our proportion. And then I need to find the perimeter of this trapezoid, which just means I do 5 plus 5 plus 8 plus 14. So what, that's 10 and 18 plus 14, 32. So 32 is the perimeter of the smaller one. We want the perimeter of the larger one. So then I'd have 2p equals 355 times 32. Divide by 2. 2 goes into 13. 32 leaves a 16. And so now I'm just doing 355 times 16, which is 5680. And this right now is in inches. So we're just going to leave it in inches. Because it just says find the perimeter and area of the actual garden. Doesn't say we need to change it, so we're going to leave it in inches. Now we're looking for the area. So for the area, since my scale factor is 2 to 355, for the area, I've got to square it. So I'm going to put 4 over 355 squared. I'm not going to figure that out. We don't need to. We'll just have the 355 squared go along with us. We need to find the area of this trapezoid. Remember, area of trapezoid is B1 plus B2 times the height divided by 2. Again, several of you are not writing this formula correctly because you're putting parentheses around the H and not around the B1 and B2. But the parentheses need to be around the B1 and B2 so that you add the bases first, then multiply by the height, then divide by 2. So my bases are 14 and 8. My height is 4, and I'm dividing by 2. So 2 goes into 4 and leaves a 2. Sorry, 2 goes into 4 and leaves a 2. 14 and 8 is 22 if I didn't mess up, which I might have. I did not. And so that gives me 44 inches squared for the little trapezoid, for the drawing of the trapezoid. And then we want the area of the actual trapezoid. So 4A equals 44 times 355 squared, which again, I said we could leave it that way. Divide by 4. So 4 goes into 44 and leaves 11. So I'm just going to do 11 times 355 squared and get 1,386,275 inches squared. And that's where we're going to leave it. We're not asked for feet, so there's no reason to put it in feet. We're just asked for the actual area, which that's a lot of inches, but it doesn't tell us we need to change it, so we're not going to change it. Okay, so now your lesson for 87 is going to be the warm-up on page 567. Then you're going to do the practice. You're going to do B, C, and D. Then, out of the lesson, you're going to do 2, 3, 4, 7, 11, 14, 19, and 29. And this is due Tuesday the 31st. That's when this is due, Tuesday the 31st. So that's your lesson. So when you look at D, you need to follow what we did with the trapezoid thing. You're just finding the area on D, so make sure you take your scale factor and you square it. So your scale factor is 1 to 10. So when you put it in the proportion, make sure you put 1 over 100. And then you're given the area, actually. You're already given the area. It's 1.5 square feet, so that should help you set up D. Make sure that you copy the notes and turn them in with your lesson by Tuesday, 3/31 at 4.